Well, thank you for a fantastic intro, David. I am going to be talking about automating your inspection with relation to three of our products today, but we'll sort of go through our portfolio. Um, I'm going to run through the different programs that we can do different levels of automation with. So depending on what your needs are, you can kind of modularly pick what you'd like to do. I'll briefly discuss the 5-axis and then we'll get on to a brief demonstration and any more questions you might have. I'm the applications engineer for Sensofar, kind of in the Northeast and part of the middle of the country. And Adam, as David mentioned, is here as well with me. So he'll be doing the latter portion. So who are we? We are a spin-off from the Technical University in Barcelona. We were founded in 2001. Sorry, is there a question? No. Founded in 2001. Our headquarters is in Barcelona, but we have locations in Asia, Germany, and our HQ in the US is in Connecticut, but we've got distributors all over the country. At this point, we've installed about 2,000 systems and climbing worldwide in industries ranging from semiconductor stuff to dental implants to archaeology, tooling, and tons of other stuff. This is our sort of flagship desktop line. We've got the S-Wide, which is really for large area measurements. We've got the S-Neox, the 5-axis, our sort of basic system, the S-Lynx, and the S-Onyx, which is just an interferometer. So our flagship system, the S-Neox, is what we'll mainly be discussing today. And as David mentioned, it's a super, super versatile system. It's got a bunch of different technologies packed within it that allow you to measure roughness, surface finish, but also grab form, shape, height, bow, warp, etc. So the technologies inside of it are focus variation, confocal interferometry, and spectroscopic reflectometry. Focus variation is really for measuring very high slopes and for grabbing form. Confocal is our best laterally resolute imaging method. Also works on pretty high slopes as well. And then interferometry is for smooth, reflective, very low step heights. And then reflectometry we can actually use to measure the thickness of metallic layers. And we'll get into a little bit more of that later. But here are some hardware options that you can add onto the system. So if you have samples that are really tall, we can install a high bridge. If you're looking at very large samples, then we can do a wide bridge. We can do a high and wide. The 5-axis, for example, requires a high bridge. Multiple options there. We also offer an 0.65 lens that does interferometry with a slightly different method than our other lenses do, and it allows for very rapid scanning of a large part for bow and warp. So that's an option. As I mentioned, we have a 5-axis arm, which allows for complete inspection of a 3D cylindrical small part. So something like like this tool that you see here, or a dental screw, a bone screw of some sort. That's all possible because we've got this rotational stage that'll spin the part in 360, and then we can also angle it to look at maybe an undercut or a flank that's sort of shadowed normally. All right. So we can also grab roughness measurements with that same device. And then finally, we have the S-Wide, which is kind of our fastest method of scanning. It's not going to be quite as resolute, but it captures an area of about 30 by 30 millimeters in one shot. It's got a full color camera. It's very fast, and it has a telecentric lens, which means you can get about 60 millimeters of depth of focus in one shot. Here's an example part being scanned in grayscale and then having the heat map applied to it. So a 300 by 300 millimeter part scanned fully. Also, if you are in a production environment and you want all of this stuff to be done in line or near line, you can take each of the heads off of its stand and integrate them into your line or whatever you've got going on. So we recently launched the S Mark II and the S Neox Clean Room, which are in the middle there. The clean room is just, our regular SNEOX head, but sort of sealed in a special way and designed for use in a clean room somewhere. And the S-Mart 2 is our very, small compact package version of the SNEOX that's designed, again, to be a bit more rugged and built for the shop floor somewhere. Cool. So kind of what we're talking about today is the automated processes in which we can inspect, move the stage around, and also then do the analysis. So I just wanted to provide kind of an overview with this slide. So Senso Scan and Senso View are going to come with any program that any hardware that you buy. And then optionally, depending on how much automation you need, we could either add Senso Pro, Senso Map, or our software development kit. So I'll sort of go through how each of those work in a moment, but I just wanted to show an overview of that briefly. In terms of manually moving the stage and controlling the microscope, that's normally done with the 3D space mouse that you can see on the left. However, you can also click and do all of those actions can be mimicked by clicking. So that allows you to connect via TeamViewer, and you can remotely move the stage around and manipulate your sample. Lastly, we also have the option for a motorized tip tilt. So if you've got samples that are really flat and you want to measure them quickly, you can one button click and the stage will actually tilt itself into perfect level. Or let's say you've got a flank or an undercut that isn't really visible, you can manually tilt the stage up into a different position to make that more easily scanned. So we've also got options for automatically moving the stage. The first is the extended measurements module. So that just allows you to stitch. So if you've got multiple fields of view that need to be stitched together, that's very easily doable. And if you say, I want to stitch in 4 places around this large dish that I'm inspecting, we have an automated procedures module that'll allow you to do that. So you can look at multiple recipes at different locations on the sample that you're looking at. So that's sort of the movement control. If you need a bit more and you're interacting with your own stage or a robotic arm that's going to pick and place stuff, we do offer an SDK that runs on like C# or C++, and that can control the movement, and it'll also trigger analysis commands if you need it to. So if you want to trigger a movement and then send it immediately to some analysis program, we can generate a tolerance report. And that also works with multiple systems as well. So you can send those commands out to 3 scan heads or 5 or whatever number you've got. Cool. So that's mostly the movement. The first program I want to go over is Senso View. So Senso View is our basic viewing software. It's very powerful. It's not quite as automated as the other solutions, but you can still accomplish a fair amount with it. So we've got a template manager here. And that template manager can be used to save any number of operators that are done on your scan. So you can see some of them here. You can remove the form, restore, threshold out, certain heights that you don't want. You can do basic roughness or profile roughness analysis and take volume measurements. So I'll just briefly kind of go over what that might look like. So this is what we call our easy or smart roughness analysis button. So you sort of put in, you give it the acquisition that you've got, and you hit the button, and based on your expected roughness and your evaluation length, the software is going to pick what cutoff values it thinks will give you the most accurate surface roughness, kurtosis, mean, peak height, or whatever parameter you're looking for. And that can obviously be saved and then repeatedly done every time you take a scan without you having to apply that again and again. For example, you could also apply the volume operator and do a basic particle count of something above a mean plane. So take a mean plane and say, I want to look at all the particles that are above this mean plane. Can you give me that, or below? And that can, again, be applied as a template and done automatically. If, however, you have a specific need and you would like it to be more intelligent as a software, and you just want a report that's a CSV file that says whether or not something's in tolerance, and you want just a quick report, that's doable with a program called Senso Pro. So Senso Pro has a massive library of plugins, and this is by no means an exhaustive list, but I've included some of them here. For example, the surface texture, the step height, an edge, 2 holes. As you can see, we've got a ton of different plugins that were all built in coordination with one of our customers, who is then kind enough to say, you can use this for any other customer you'd like to. So we have a massive library of these. Here's just a couple more of them. And the basic idea here, as I've explained before, is that you would acquire the data, then send it to Senso Pro, and you get results in CSV or Excel file. So kind of just to look at a few of them, for example, the concentricity plugin looks at what the top diameter of something is, what the bottom diameter of that hole is, and then it measures the X and Y distance and gives you a number of how, based on how far apart those two diameters are. So that's one that a PCB customer was interested in. Now, someone making razor blades, for example, might be interested in looking at the cutting edge of their blade. And they're also interested in a couple, the rake angle or a couple of other metrics that are specific to their needs. So we built a plugin for them to tell them some info about that. And this is kind of what a readout from that might look like. Or, for example, you are interested in taking multiple profiles across a trench or a groove and looking at their depth, their width, their max width and depth, their average, whatever you'd like. That's possible as well. And then lastly, the bump plugin, again, for the semiconductor industry, that analyzes a ball grid array pattern and tells some information about that. So all of these were built in coordination with a client or a customer of ours, and we have a small enough company and a really, really talented software team that we can pump these out quickly and make them exactly sort of what you'd like to do. And we've built tons and tons of these, so we're pretty adept at it. In terms of how the workflow kind of works, you can either load one set of data and just analyze that, or analyze multiple, maybe from different weeks or different months, and compare the two sets of data to up to 6 sets of up to 1,000 files. So you'd set your filtering parameters, hit analyze, and then you'll get some sort of rating that kind of looks like these curves down here. And if you don't know what parameter differentiates your sample best, this rating is a good way to kind of say, well, the standard, the surface roughness differentiates them pretty well, but the max peak height isn't a great metric, so we'll stop using that and we'll instead switch to the surface roughness. Here's just another example of kind of what that looks like visually. We have a lot of customers that notice that something is different between their samples, but they're in the process of, as David mentioned, kind of taking this and automating it so that it's not quite as subjective to the person that's looking at it that day. And instead we can say we now have found a metric that really accurately describes what's different between these two. So besides that, Senso Pro also can tell you what's in and out of tolerance, and then you'll get a report on each individual scan, and you can go back through and look at them later. So this can be linked with Senso Scan and triggered by Senso Scan, or you can do it afterwards and just take a look at everything on your own time. So that is Senso Pro, and the final software that I'll talk about is Senso Map, which is our kind of most advanced analysis software. Senso Map is sort of the most powerful and most complex to wrap your head around and understand how to make work. It's a little bit slower than Senso Pro or Senso View, but it gives you, as you can see, these modules that are just have a bit more flexibility and are a bit more powerful. So it works in sort of the same workflow. You take you acquire your surface data, and then perform some sort of metrological study on it, and then create a report. Now, the report creation, again, is a bit more powerful than just being able to spit it out to an Excel or CSV file. You can actually sort of edit it like a Word document or a PowerPoint that has 3D data in it. Maybe some of you are already familiar with Mountains Map. So these are just some of the modules that you can do, some of the metrological analysis you can do on the right. So what does that look like in practice? something like this, where you've got 3D data and all of these little boxes can be moved around and placed in a way that works for your team. And this is just a surface topography analysis of a scan, and then some parameters, performed on that. We can also do a step height analysis, but unlike a plugin in Senso Pro or SensoView, you could do 10 step heights in one scan and then make that a recipe and do that over and over repeatedly. And that's completely customizable by you. Finally, I just included the particle analysis bumps section as well, just to show that that's a possibility in Senso Pro, but it's also a possibility in Sensomap. And then you can kind of move around and show it in a different way. Particle analysis is also another area where Sensomap really excels. We have a lot of customers now that are interested in looking for defects on their parts, and you can get statistical values and any analysis you'd like of that particle. So looking for a particle that's larger than a certain size or below a mean plane is totally doable in Sensomap, and it's kind of our best option for doing that right now. So that sort of concludes all of the software analysis stuff, and we can talk more about that later. But I just wanted to briefly kind of go over how using the 5-axis gives you more options for automation as well. So our 5-axis unit, as I mentioned earlier, allows you to take and characterize the full 3D shape of something. So a tool, a bone screw, something like that, something small and cylindrical can be completely characterized by the 5-axis. So you just place the tool in there, and then after you've set up a recipe, it will do that automatically for you. So you can then, look at it. Just a couple more. Yeah. So that's just, showing the flanks and everything on that screw there. Cool. So then we can then import that and compare it to a CAD file and look for areas where there are deviations, and we can export any of our files into something that works for you, like an STL, PLY, X3P, etc. And that's possible with SensoView or Geomagic or a file that's generated by the 5-axis system. You can then take profile analysis on that, gather the angle measurement, the radius measurement, or some sort of distance. So the 5-axis, again, just kind of opens up another area for further automation. I think that's all I've got thus far, and I think I will turn it over to Adam to do a brief demo. But thank you very much, and I think we'll do some questions at the end of the presentation. All right.
Hey, Adam, I think you have to mute one and unmute the other one.
Thank you, David. And thank you again, Daniel, for the presentation. So I'm going to share my screen here. Let me know, David, if you're able to see that.
Looks like a lot of data real fast. Looks good.
We can see it. Yep.
All right. So as Daniel mentioned, we have some programs that allow us to automate analysis. And what I'm going to show you here in this presentation is a roughness standard that's on our main SNEOX microscope. So we're looking in live time right now at a rough patch on a sample. And we're first going to just check to see if we're getting a decent visual image of it. And then we're going to work to take multiple images across the surface, and we're going to compare them in Senso Pro to see which parameters are most alike and which parameters differentiate. So step one, for this type of sample, interferometry is usually the preferred imaging mode. So we set a range of 20 microns, top and bottom, and we can simply hit acquire. So we're going to see what type of result we get from that. And if we like the results, we're going to save that as a recipe. So the microscope just did a scan, and this is the general result that you can image in Senso View, which Dan had pointed out. Any type of linear measurement is possible. You also have your ISO standards that are available as well, but that's not really what we're going to focus on in this application. So we're going to go back to Senso Scan, and we're going to save this right side workflow as a recipe. So I'm going to come up to the top and hit Save As, and we're going to call this CCAT 1. And now I'm going to use that recipe to apply the same acquisition to multiple points in X and Y on the surface. And we do that by making a program called MMR, which is Multiple Measurement Recipe. So I open this up, and I'm going to title it CCAT1 as well. And I'm going to use user selected, where I can simply choose the location in X and Y that I want to use. But we also have the ability to move it a die pitch, and we can set that to as many millimeter spacings as we'd like. We see this common in semiconductor for wafers. Or we have the ability to load a text file where the microscope, because it's motorized in X and Y, can move to those coordinate positions. But as I mentioned, we're just going to user select it. So I hit new, and I like this location. So I'm going to add the position. And now I'm going to move in X to a new position. I'm going to add that. And I'm going to move in Y to another position. And I'm going to add that. Now, from what I had saved in the previous window, I'm going to apply that recipe to these 3 positions. So I come here and I look for CCAT 1, and that's the recipe, and I open it. And now it's applied to all 3 locations. So from here, I can simply tell it to move to a folder that I want to save on the desktop, so I'll find it later. And then we can run our acquisition. So I've defined it, and now I can acquire it. So the microscope moved to that first position. It's going to do an autofocus, and then it's going to acquire the image. After that's done, it'll move automatically to the second position, which it just did there. And you can see where it's located at the bottom. And once this is complete, it'll move to the third position, where we'll then have those 3 images in the folder that I saved on the desktop. We can tie this all as automated, but I wanted to show you the individual steps. So these are the 3 images that now we will open up in Senso Pro. So off the desktop here are the 3 that we took. And Senso Pro now populates them on the left side. As Dan was showing you many of the plugins, these were all generated from working with customers over the years. But we're going to use our surface roughness, which is the SA25178 plugin. And I can select that. And from here, you have the ability to apply any of your filtering. Maybe we'll do an 80 for the L filter and a 2.5 for the S filter, and set any of the parameters that you're looking for in the ISO. So for example, SA a tolerance could be set between 1 and 10 microns, or to whatever surface roughness value you're looking to isolate. But the point of this software is that from the initial acquisition to this final step where I hit analyze, this can be completely turnkey, where an operator simply loads a sample, calls the recipe up, and hits acquire. And then what you'll have at the end of that is a CSV report that shows you all the values. So the microscope just went through and imaged all the samples, which shows that they're actually all out of tolerance to what I've set. But you have the report here that you can come back to and check in your manufacturing process any sample that might have been flagged as a failure. And then if none of them were flagged, you can say your sample batch run was a success. We can take this one step further now, where I might want to compare a batch against a batch. So here I have the sample A, And now I'm going to call up sample B, which was a previous images that I took earlier today. So we'll take a look here at these 3 images. So now what I'm going to do is I'm going to compare sample A to sample B so we can see which parameters are most alike and which parameters are most different. And I'm just going to take off this tolerance here so it's not looking for any specific tolerance as it analyzes. And we hit analyze. So now we have a report that says they're all intolerance, which will be the same as the last report. But we can take this a little bit step further where when we select multiple group, we have the ratings that Dan was showing us. And it's saying, it's a little counterintuitive, but it's saying actually these samples are very similar in SA because it's actually the same sample. So the distribution is very close, but the green, it's saying it's very different. So there could have been a change on the sample as we have about an inch by an inch area in X and Y that we covered. And there may be some damage to one of the sides of the part versus the part that we imaged here. So we should naturally have a different result, which you're seeing here in this bottom center area. So this is how Senso Pro ultimately operates for our customers. And we use this mostly for QA, QC checks. It doesn't have to be done with surface roughness. We have samples that are customers are looking at step heights or traces. Really, every single industry, a recipe or a plugin has been made, as you're seeing here on the right side. And if you do have a very specific type of application, as Daniel mentioned in his presentation, we would be happy to engage you and work to create a custom plugin for you if that helps you with your manufacturing process. So on my end of the demonstration, please let us know if you have any questions. Daniel and I are always available to speak with you now or in the near future. And thank you again for joining our webinar today.